This is Caffeinated Risk, the podcast for security professionals by security professionals. Here are your two self-proclaimed grumpy security guys, Tim McCree and Doug Leese.
Welcome, folks, to Season 4 of Caffeinated Risk. For our next podcast, we got to spend time with Andrew Ginter, the VP of Industrial Security with Waterfall Security Solutions. Andrew's been an amazing security voice in the industrial cybersecurity realm for over 2 decades. Andrew leads a team of experts responsible for industrial cybersecurity research, contributions to standards and regulations, and security architecture recommendations for industrial sites. He's also led the development of software products for SCADA systems, IT/OT middleware, and OT security while at Hewlett-Packard, Agilent Technologies, and Industrial Defender. Andrew wrote his first book on SCADA security in 2016 and followed that with 2 more textbooks on OT security in 2018 and 2023. He's achieved his Bachelor of Science in Applied Mathematics and Master of Science in Computer Science, both from the University of Calgary. And now, let's check out our latest podcast with Andrew Ginter. I wanted to ask, Andrew, have you had success explaining these to executives or to those who hold the financial purse strings? And don't get me wrong, I'm a real big fan of sock puppet simple, and I've used that often in my career. But have you had any luck moving this message forward with executives for your clients or within organizations you've worked in using that same approach?
Mixed results historically.
Okay. Recently,
there's something new in the world that I've had very good results with, and this is the U.S. Department of Energy is funding Idaho National Laboratory to do something called cyber-informed engineering, not to be confused with consequence-driven cyber-informed engineering. It's a longer name. It's a subset. It's a proper subset of cyber-informed engineering. CIE is the big picture, and CIE is positioned as, positions OT security as a coin with 2 sides. One side of the coin is cybersecurity. Teach engineers about cyber threats, teach them about cyber mitigations, teach them about the limitations of cyber mitigations so they can evaluate to what degree the mitigations address the threats. The other side of the coin is engineering. If your life depends on a boiler not blowing up in your face, a 6-story boiler, would you prefer how would you prefer to be protected from a cyber attack that overheats the furnace under the boiler and overpressurizes the boiler? Would you prefer a mechanical overpressure relief valve? Or would you prefer a longer password on the PLC controlling the boiler? Or maybe an encrypted connection to the PLC controlling the boiler? Most people say, I would rather have the relief valve. The gurus say, Andrew, you're deceiving us. Yeah. You're asking the wrong question. I want the overpressure relief valve. I want 4 of them because, there's metal fatigue, there's corrosion. I need at least one of the 4 of these things to work to save my life if that boiler overpressurizes. Yeah. And I want the encrypted longer password on the PLC. And I want an absolute boatload of cybersecurity beside it because this is my life on the line. And that's the right answer. It's a coin. You don't spend one side of the coin or the other. You spend the whole coin. But the thing is that the engineering contribution, the engineering side of the coin has been ignored. Mm-hmm. And when I tell this story, and I've got levels of detail below this, but, we wanted to talk about risk, not necessarily CIE, but, CIE includes an engineering perspective on risk. It's the way that engineers think about risk is included in sort of that, the methodology. And that sort of message has been much better received than my message historically. Again, there's no consensus, but the loose reaction I get, again, flying high and slow, 75% of the people I explain this to, be they board cybersecurity subcommittees or engineering teams, all the way across, the 75% reaction is, what a good idea.
Yeah.
And the question they ask is, why is this new? This shouldn't be new. This should be how we were doing this for the last 20 years. Why is this new?
Yes.
This is a good idea.
And you're right. It's difficult for an executive or for leadership to wrap their head around it until you can explain it just how you have, because now you're right. It is both sides of that coin. We need to look at both. And I agree. For the longest time, we haven't involved the engineering side of the house, right? It was always an us and them equation when we came to risk assessments. And that has to change, right? It has to change.
Absolutely. And the sort of a different story I tell is, look, there's, what's the right word? It's a truism in the industry that, IT and OT teams don't get along. And it's not true. It's, again, that's a gross oversimplification. There are lots of examples of places where this problem's been solved. Unfortunately, there's still a lot of places where it hasn't been solved. But to me, in a sense, what makes the problem obvious, and to a degree makes the solution obvious, IT is told engineering's done a terrible job of OT security. It's your job now. Go fix this problem. And they come down and say, patch everything.
Yeah. Mm-hmm.
And the engineers go, no. And well, bang, bang, bang. There we go. It's, large conflict. If the engineers returned and said, I'm happy to do that as soon as you can explain to me how likely that is to kill anyone.
Mm-hmm. Yeah.
What? And the moment you get a stakeholder to say what, the moment you get them to start asking questions, that's the moment you start getting useful dialogue. And so, you explain the engineering change control discipline and why it exists. And even if you get a good answer, and it's really hard to get a good answer for how likely is this to kill anyone, the next answer you need is how likely is this to trip my $12 billion pipeline asset?
Mm-hmm.
How likely is that? I don't know. And so, the moment you get that's where you get dialogue, but then you turn the coin over. And the next logical question for the IT team is, okay, it's going to take a very long time to patch anything. How are you going to address this risk if you can't patch for it?
Yeah.
What? So, now the engineering team's going, what risk? And again, once you get these practitioners, once you get these stakeholders starting to ask each other questions, you wind up with useful dialogue. And, the CIE team was prototyping their stuff. They prototyped it with a class of cybersecurity practitioners. They didn't say who they were, but the sense I got was they were most of the Active Directory administrators. Mm-hmm. And they sat them down with a network diagram for a small electric power distribution system.
Okay.
And they said, apply the methodology. We've taught you the methodology for 2 years. Apply the methodology. Okay, they said the first step is to determine worst case consequences. What are we worried about? And, somebody in the room puts their hand up and says, I've heard about this thing called a cascading failure of the power grid, where, the relays just trip, things get overloaded, the whole grid, all the lights go off.
Yeah. Yep.
Could a worst case sabotage of our little distribution system cause a cascading failure? And everyone in the room looked at each other and went, I don't know. Mm-hmm. They didn't have the expertise in the room. I looked at the network diagram. I know a little bit about cascading failures. I looked at the network diagram. They didn't even call out where the protective relays were in the network. And I'm going, you don't have anything like the right information, even if you had the right people in the room. And so, the first lesson of CIE is, it takes a village. Mm-hmm. IT can't come in and do it. Engineering can't do it. There's too much knowledge that's needed. I've lost the track of what my point was, but this is where we wound up.
No, it's awesome. I like this because it is exactly what we do with ESRM. Like, we've been applying this, for not as long as you folks have, but we've been looking at ESRM, this risk-based approach to security. But it's a collaborative approach where we literally have to bring in more than just the security team, because you have to get away from that bias, that the blinders that we all have on the security side of the house, and to bring in others. So, we've been on this podcast talking about, have you brought in the finance folks and legal and insurance when you're looking at a corporate risk? But this is an amazing opportunity to start talking about from your space. Have you actually talked to the engineers? Like, and if not, what the hell are you doing? Why are you deciding what a risk is without the actual experts in the room? And I think, to me, that's been the eye opener for all of this, is why are we not bringing in more experts into that room?
Absolutely. And the experts have a lot to contribute. It's not just that the experts can say, oh, here's exactly in one syllable words how the whole thing can go boom. They can also say, no, that scenario there is not credible because we have overpressure relief valves and mechanical breakaway clutches and so they know about the design of the physical system. You don't have to guess and say, well, I guess the worst case is that everybody dies. No, that's not actually possible. It's not physically possible. And so, there's good news. There's bad news, yes, but there's good news. When these teams get together, they wind up with a much more useful assessment of what is at risk. And then, of course, what can we do about it? And, the thing that the IT people bring into the room is a deep understanding of threat.
Yeah.
Well, what is the threat? Well, show me your network. Okay. Patch levels, bang, bang, bang. I mean, that's not good. How did you do that? In my experience, a lot of engineers are focused on doing engineering. They don't want to be IT people. But if you show them a threat to the physical process or to the safety and well-being of the people who are operating the physical process, they go, what? Because if it's a threat that hasn't been addressed, it rings huge alarm bells. Explain this to me in one-syllable words. And, once they understand the threat, now they're going to start asking questions about what do we do about that? What's available? Well, you can use antivirus. Well, what's that going to buy me? Well, the easy way to break antivirus is to, write a new virus that the signatures have never seen before. That's not good. And now you can have you can have a conversation.
Circling back to the point I think you were going for, because I found it in your book as well, is the explanation of how the engineers may spend a great deal of time deliberating the actual breakdown of a system. And you were asking the readers to move up a level, using your words, getting higher and slower. You talked about how they originally started out with, we can only tolerate a 1-day outage or something. And then when the finance folks got involved, it figured out we could actually be down for 30 days and still be open for business. How do we get to that business driver and the real impact, including nobody dies, and figure out that acceptable risk at the right level before we get down into the minutia to figure out whether that's a viable threat or not?
So, short answer is it's not easy. There's a lot of knowledge has to be in the room. And part of the answer is, the first step in that direction is figuring out the consequences. And when we talk about finance, the engineers had the naive assumption that the consequence of the plant going down was that part of society wouldn't have power. They didn't really have a deep understanding of real-time electricity markets, and buying and selling electricity, whereas the finance people live that space. And they came back and said, no, we just have to pay a little bit more and buy power from somebody else. There is spare capacity. Yep. And so understanding the consequences, sort of the first part. But even that, before we get to the second part, even that particular example in the book, if you read a little bit further, if I remember correctly, talked about blind spots. Yep. Saying, you talk to the engineers and they say X, you talk to the finance people and they say Y, you go, oh, it's not as bad as I thought. And you've missed the ability to destroy the turbine.
Right.
What?
Yep.
A widespread blind spot that I observe is bricking devices.
Oh, okay.
You've missed the ability of the attacker to go in there and erase the firmware so thoroughly that the machine can't boot up enough to put new firmware in, and you got to replace the PLC or the circuit board in the turbine or something. And if you destroy enough of these devices, you don't have enough spares anymore.
Correct.
People stock spares assuming random equipment failures. They don't stock spares to replace everything in the case of a cyber attack, destroying everything. And so these blind spots, I've lost track of how many times I've seen a chief information officer stand up at a conference. We do a lot of conferences, and boast about how the lights will always stay on. Nothing can get in and impair. And I'm going, you haven't talked safety at all. No, safety is looked after. We have electromechanical safeties. Okay, what about equipment damage? What?
Mm-hmm.
It's not considered. What I observe is that too often we are distracted by high frequency, low impact events. Somebody fumble fingers a command line on an old school PLC and, trips the plant.
Mm-hmm.
That's not a cyber attack. But if you put the right permissions in place, you can prevent someone from giving a command that would trip the plant because they don't have permission to give the command anymore. So you go, I can use security to increase the reliability of the plant.
Yep.
Yeah. And that is the highest frequency. That's in the cyber world, it's not really an attack, but a lot of plants go down because of human error.
Correct.
Yep.
Is that what we should be designing our security program for? I don't think so. I think we need to look at the other extreme. Low frequency, black swan events, they're called.
Mm-hmm. Yep.
High impact. Somebody gets into the cloud and bricks all of the PLCs from this vendor in the world. Nobody has inventory to replace that many PLCs. Now what?
Yeah.
A lot of stuff goes down for a long time. The feedback I got in the Gold Book so far is, Andrew, your chapter 6 needs work.
All right.
And chapter 6 is talking about risk. I'm working on a rewrite of chapter 6 based on that and other feedback. But I think one of the essential concepts is the concept of credibility.
Yeah.
An extreme example, nation states coming after us. Nation states, the truism is they have essentially unlimited money, unlimited talent, unlimited time. Given enough time, money, and talent, you can break anything.
Correct.
Is that a credible threat? If it is, why is it credible? Is it credible because of the nature of the business? Is it credible because of the importance of the business to the society? If the society is involved and we've got a situation like where that's a credible threat, we probably have to tap the government on the shoulder and say, can you help us out here? Because we've done the risk analysis and it looks really grim.
Mm-hmm.
And if it's not a credible threat, I grew up outside the town of Brooks, Alberta, on a farm. Brooks is 15,000 people, maybe 10,000 subscribers in the water treatment system. The Russians could buy a sleeper cell of 3 cyber gurus, cyber experts, digging with shovels in the workforce of the town of Brooks water system with credentials to log into the occasional system, and they could trigger a cyber attack through those experts 5 years out.
Mm-hmm.
Is that a credible threat? Town of Brooks, it's an agricultural community. It's 10,000 people. They're capable of it. Capability, yes. Credibility, I don't think so.
Yeah. What's in it for the attacker just doesn't hold up, right?
Yeah. Is that a credible threat for the city of Washington, D.C.?
Different conversation.
Different conversation. And so that's what I'm working on, is not the concept of likelihood. I don't think likelihood is the right theoretical model for risk. At the very highest level, dumbing it down, I think the right model for high consequence, for low frequency events, is credibility. It's still a debate as to is it credible or not, but at least now we're arguing about the right thing. We're not all agreeing, yes, it's low likelihood.
Yeah.
We're saying, is it something we need to defend against or not?
And I like that because I've had those discussions with executives in my career on the cyber side, and also on the physical security side. And Tim, how credible is it? Or where was your source? Or do you know what I mean? Like those types of discussions, those were the ones I love to debate, because now we're talking about a particular, like an actual event that has a particular impact and a consequence to the organization. Is it credible? And I think if there's any way you can craft that, we would love to see that, because it just changes the discussion with executives, because I'm getting tired, and I know Doug is, and others, of explaining how often and how bad, and this is what we found. No, can we focus on if we can, I hate to say word because that makes it so simple, but can we focus on a different word to explain to executives the credibility of what we've uncovered? That, I think that would be a turning point with some discussions, right?
I think so. And The word, one of the things I like about the word is, and I've tried a few other words, is that it's clear that we're making a judgment call.
Yes.
Whereas likelihood, it sounds like you're trying to estimate an objective reality, the probability of an attack. And, we are using a qualitative estimation because it's difficult to get a quantitative estimate of a real thing. I'm sorry, it's not, there's not, attacks are not random. There's no probability out there. It's a different thing. We shouldn't be, when we're talking credibility, it's clear that we're exercising judgment. And now we can argue about how to exercise judgment instead of arguing about an objective thing that doesn't exist.
Yeah. Agreed.
What I did document in chapter 6 that I think I got right was the concept of design basis threat. And this is something I picked up from people who practice this. And the concept is out of physical security. If you build a nuclear reactor, if you build an embassy in Iran, there's a classified document that I've never seen. I don't have a security clearance, so I know very little about it. But what I know about it at the very highest level is that it describes the most capable threat that the physical security system is designed to defeat. A nuclear reactor, you must withstand a direct impact on the containment dome by a 747 fully loaded with fuel without a radiological release. Oh, and the engineers can look at that and say, then this is how we have to design it. Okay.
Yep.
With an embassy, you will withstand an attack by up to 6 terrorists armed with submachine guns and hand grenades, trained for 3 months at this base in Iran. You will defeat that. But if you got a squadron of tanks driving down the road, blowing holes in buildings, that's above the line. And so you draw the line. It's the design basis threat line is the most capable threat that you are designed to defeat. You can do this in the cyber world. A cyber design basis threat. What do you call the threats above the line versus below the line? And again, the word I've heard used in the industry is the word credibility.
I'm glad you brought that up because I was going to ask about the design basis threat. It reminded me of the security level concept that they put in 62443, where they said if you need to be at this level of attacker, these are the control capabilities that need to be in place.
Yeah.
But I'm wondering if the whole design basis, because it's not a checklist, actually opens us up for a more concrete conversation about what's real. You could theoretically go through the SL levels and go, yep, I've got that. I've met all the defined requirements for a level 3 defense capability, right? But have you really? Because all you're measuring is for authentication at level 3, thou shalt have X, X, and X. But what if authentication isn't your problem for the threat you're worried about? It doesn't translate, whereas this design basis puts us in that conversation. Like, don't tell me about a specific control. Tell me about the damage you're trying to avoid. I think it's an interesting twist on the approach.
It's a tricky one. 62443 is a tremendous asset.
Yes.
It is the world's most detailed cybersecurity standard. Nothing else comes close. It's going to be 14 volumes. I think there's 8 or 9 of them in existence already. It's huge, but it's not a formula.
Correct.
Okay, you can't say do 62443. There, I'm done.
Yeah. Here
are some examples. It's tremendous. It's a huge resource. Don't get me wrong, but I see way too many people talking about 62443 as though it were the Bible. Every word is true, and I'm going, I was on those committees. And one of the issues I'm on the update of 3-2, which is risk assessment.
Yep.
And you talked about the security levels, and it says in 3-2 in the introduction, the goal of the risk assessment methodology is to define your zones and conduits and assign a security level target to each zone and conduit. And I'm going, yes, that's absolutely what you need. And so you look at the flow chart that says, how do you do this? And you go through the steps, and I'm looking at it. And the piece I care about is, the what's credible. So I'm looking for what advice do they have for me? And there's a section in the flow chart, numbered, 4.2 or something, that is, now that you've got all the information, evaluate the information and assign the security level targets. I said, that's what I want to read. I flipped through the diagram or the document. I get to the section. It's one paragraph long.
No,
it says, pick a methodology and apply it.
Yeah.
Oh,
thanks.
So I'm on the committee. I'm saying to the other people on the call, we meet every 2 weeks or something like this. I say, look, there's a problem here. We need something better than this. And 3 people on the call are saying, we were there when this was drafted. The reason it's like that is because we had 17 people on the call every week or two, just like this one, and we could not agree on the criteria.
Aye.
And so we said, fine, punt. That was a decade ago.
Yeah.
And so now we have an opportunity to apply, a decade's learning and hopefully do something different. So, but there's a second one. The criteria weren't there. The other thing is, even if once you've decided what target to apply, the targets are defined in terms of the capability of the adversary. SL4 is, they don't say it, but it's basically a nation state. I dumb it down to a nation state. SL3 is, I dumb it down basically to organized crime, ransomware, and so on. The problem, a problem with 62443 is that a lot of parts of it were written 10 years ago and currently are being updated. And so what was the threat environment 10 years ago, what nation states were doing to each other, what ransomware was doing to us 10 years ago is very different from what they are doing to us today.
Absolutely.
And if we blindly apply the standard as, the word of truth incarnate in the standard, and say, there, we're done, we don't take into account today's threats, and we need to do that.
Do you know what it does for me? Spending a lot of time with strategy side and with executives, it gives a chance to talk at a different perspective. The concept of credibility and looking at things from a design perspective, for me, those are fundamental parts of what we've been trying to do for a couple of decades with the SRM. And you folks are establishing it on the OT SCADA side of the house. And I think there's this journey we all need to take together. And I think you've already started it. So thank you for that. I appreciate it.
My pleasure. And I would remind you, my older books are available on Amazon if you want them. My latest is still available for free from Waterfall. Waterfall's giving them away. We sell technology, not books. Go to, waterfall-security.com/engineering-grade-OT-security. And there you go. You can ask for a free copy. We don't ship the whole world over. Some people still have to go to Amazon. The second book, the Black Book, the essential chapters of the Black Book are reproduced in Appendix B of the Gold Book.
Nice.
So you don't have to buy the Black Book to get some of the older stuff. The Red Book, where I criticized everything, if you want that one, you have to pay for it. There you go.
Yeah.
But if we bring it to a conference, Andrew will sign it for you.
I was going to say, yeah, we can do that too.
Oh, absolutely.
Well, thank you again, sir. Really appreciate it.
Thank you so much. It's been a great pleasure.
Thanks for listening to the latest podcast from Caffeinated Risk. Make sure you visit our website, caffeinatedrisk.com, to stay up to date on what we've been working on. Our website has bios of our podcast guests, posts about topics we're passionate about, and even a library of reference material we find valuable in the work we do every day. And don't forget to subscribe to Caffeinated Risk on your favorite podcast service. This way, you'll be notified when we release our next podcast, and you can listen to our previous guests just in case you missed them. Thanks so much for listening to Caffeinated Risk.